The other thing we're asked to do from time to time when we're trying to take a parent function and move it around, translate it, dilate it, reflect it, is to write the equation of the function in having been given the information about the graph. So for the one that we see here, a new function g of x. So we're going to have this new function that's based off of the original absolute value of x. The original is called f of x. And we're being told that this one's going to be moved up 4 units. And so there's two ways that we can write the function. One is the most familiar, and what we've been seeing in all of our examples to this point. We say that's in terms of x. And then one is a more generic format that makes it so that it's interchangeable with other functions besides the absolute value of x that we're focused on at a particular moment. And we say that that's writing it in terms of f of x. So in the first one here, we're going to stay in the familiar zone. So it says, again, we're going to have this new function g of x. So I'm going to write down g of x equals. And so what g of x is they're telling us that we're going to take this original function, absolute value of x, and we're going to move that graph, we're going to translate it up 4 units. And so hopefully we remember that when we want to translate the graph, we add something, when we want to translate the graph up and down, we're going to add something to the outside of the absolute value. And if we want it to go 4 units up, then I'm going to throw a plus 4 right here. So this is writing the function in terms of x. And so I would be able to now plug in numbers for x here and then generate my graph, or we could use the experience that we had from before, where we're just using the translations to sketching. So we can also keep things kind of general, like I said, generic, to where maybe our f of x is absolute value of x. Maybe our f of x is x squared. Maybe it's the square root of x. So it almost doesn't matter what that original function is. All that matters is that we understand what are the changes we're supposed to make to that new function. So again, we want a new function g of x. So g of x is going to equal. Now, instead of using absolute value of x, we're going to just write f of x over here. And we're just going to make the changes that are being described using just f of x instead of actually writing the absolute value of x. So we're basically just using this side of the little statement instead of this side. That's what it means to write it in terms of f of x. So what do we need to add to it? Well, that's where they're getting into the dilation and the reflection. So it says we're going to dilate the graph by a factor of 3. So that means we're going to multiply our original function f of x by 3. And then we want it to reflect across the x-axis, which hopefully we recall requires a negative sign out front. And so this way, this f of x, like I said, it might be absolute value of x, it might be x squared, it might be square root of x, but whatever that original function is, I'm dilating it by 3 by having the multiplier out front, and I'm reflecting it across the x-axis by having the negative sign out front. Now, if we had wanted to write it in terms of x, then we would just replace that f of x with the absolute value of x. And so for the last one, we're again going to write g of x in terms of f of x. We're going to use this same kind of general statement. So ultimately, again, it doesn't really matter that f of x, we're told that it equals the absolute value of x. Our function could be anything. We just have to correctly interpret the information about how this original graph is going to be changed. So it says that we're going to translate, should be an S in there, my apologies, translate the graph 6 units down. So that means we're going to have f of x. If we want to move up and down, we're going to do that on the outside of the function. So I'm going to have a minus 6. And then we want to move the graph to the left 5 units. So if we recall, if we were writing this in terms of x, so if we had like an absolute value of x, if we wanted the graph to move to the left, we'd have to add or subtract something on the inside. And so if we want to go to the left, we're going to add. It's the opposite of the positive and negative sign that we would expect. So we would write absolute value of x, and then we'd have plus 5, and then that would move us 5 units to the left. But now that we're writing it in this general form of f of x, all that's going to change is inside of the parentheses here is where that plus 5 is going to happen. Tracking with that same idea of we're adding something to the x before we take the function's action. So before we take the absolute value, before we square the number, before we take the square root of the number, whatever f of x is supposed to do, we're going to add 5. That's going to move that graph to the left. And then we're going to subtract 6 on the outside, which is going to move the graph down those 6 units. So we'll explore this idea in more detail in one of our warm-ups next week. But again, the idea here is we just have 2 different ways that we can write the formula for a function, having been given some information about it. One is in this specific format where we know what the function is, so we write it in terms of x. And then we've got this other more general, this generic format where we don't even care what f of x is. We just apply the translations in the appropriate places with the -3 out in front multiplying the mystery f of x with the +5 on the inside with the -6 on the outside as we saw in the last example.